In this video, I'm going to show you how to build an Internet of Things application using the Raspberry Pi Pico W, Micropython and MQTT. By the end of this tutorial, you'll be able to build an IoT system for collecting sensor data, publishing it to the cloud using MQTT, and then visualizing the information on a dashboard. My name is Kudzai Manditereza, and I regularly publish Internet of Things tutorials on this channel. So if you don't want to miss any tutorials on the latest technologies in Internet of Things, then make sure to subscribe and click on the notification bell. Let us begin by taking a closer look at the Raspberry Pi Pico W microcontroller board. The Pico W is part of a family of microcontroller boards from Raspberry Pi that includes the Pi Pico, Pi Pico H, the Pico W, and the Pico WH. The main difference between the Pi Pico W and the other Pico boards is that it comes with inbuilt Wi-Fi connectivity, hence the W. This makes it well suited for building Internet of Things applications, as I'll demonstrate in this video. Now, the first thing that we need to do is to select a sensor that we're going to use to measure physical quantities such as temperature. For our project, we're going to use the BME280, which is an environmental sensor that's built for indoor monitoring of temperature, pressure, and humidity. It exposes an I2C interface for reading the sensor data that it generates. I2C is a serial communication protocol that uses two lines for exchanging data: a serial clock line, or SCL, and a serial data line, SDA. So I'll be connecting the BME280 sensor to one of the Raspberry Pi Pico W's I2C interfaces. Let's go ahead and start wiring up the real hardware. So when you buy the Raspberry Pi Pico W, you either buy it with the pin header soldered in, or you can buy the pin header separately and solder it in yourself. So I purchased mine without the pins, and I've since soldered them onto the microcontroller board that we're going to be using for this demo. After soldering the pins, I have placed my Raspberry Pi Pico W on this breadboard, and I've used some jumper cables to connect it to the BME280 sensor. To gain more clarity on how these two are connected, let's take a look at the circuit diagram of my hardware connection. I have my BME280 sensor connected through the I2C interface with serial data line and serial clock line connected to pins 1 and 2 of the Raspberry Pi Pico W respectively. Further, I have ground on BME280 connected to pin 38 of the Pico W, which is also ground, and I have VCC of the BME280 sensor connected to pin 36 of the Raspberry Pi, which provides 3.3 volts output. Now, while you can program your Raspberry Pi Pico W using languages like C and C++, the easiest language to use is Micropython. Micropython is a full implementation of the Python 3 programming language that runs directly on embedded hardware like the Raspberry Pi Pico W. To program the Raspberry Pi Pico W using Micropython, you need to begin by installing Micropython on the device. First, you need to get a micro USB cable for connecting the Pico W to a computer via USB. Next, push and hold the boot select button on the microcontroller board while you plug your Pico W into the USB port of your computer. When your Pico W is connected to the computer USB port, release the boot cell button. When you do that, you'll notice that a mass storage device called RPi1, RPi2 will be mounted on your computer. This is where you need to copy the UF2 bootloader file to flash your Pico W with Micropython. Now, the next question is, where do you get the UF2 bootloader file? To get the UF2 file, you visit the documentation page on the Raspberry Pi website. So on the home page of raspberrypi.com, you go to Documentation, select Microcontrollers, and then select Micropython. Now on this page, you will notice that there is a list of instructions to follow, And there is also a link for you to download the UF2 file. So I'll click to download the Raspberry Pi Pico W version of the file. And then I'll open up the folder containing the file. Copy the file. And then paste it into the RP1, RP2 storage that was mounted when I connected my Pico W to the computer. When the file has been successfully copied, the Pico W will automatically detect the file and reboot, and then it will be ready to be programmed. Next, to program the Raspberry Pi Pico W using Micropython, we need to use an IDE that would allow us to access the Pico W from the computer and program it. The easiest Micropython IDE to use for this case is Thonny. You can download Thonny IDE by going to www.thonny.org and downloading a version that works with your computer's operating system. I will download Thonny for Windows. After installation, you need to open Thonny. Next, you go to the bottom right corner where it currently says local Python 3 and then select Micropython Raspberry Pi Pico. Now make sure your Raspberry Pi Pico W is plugged in, otherwise it won't show up on the list of deployment devices. Now after that, you should see your Thonny terminal indicating that you are now working on the Raspberry Pi Pico W. To test that our Raspberry Pi Pico W is working, we can run a hello world command by executing print hello world in the terminal. Okay, so as you can see, our Raspberry Pi Pico W has successfully executed the print hello world statement. Now that my development environment is set up and ready, I can begin writing the code for my IoT project. Before I start writing the code, I'll need to save the program file on the Raspberry Pi Pico W. To do that, I'll go to File and then click on Save. And then here on the Where to Save File prompt, I'll select Raspberry Pi Pico. Now, if you want your program to automatically run each time your Raspberry Pi boots up, you must give your file the name main.py, which I'm going to do. And then click OK. So I've got my program file saved on my Pico W. Now I can start writing code. Since I'm going to read data from the BME280 sensor and publish it to the cloud using MQTT, I'll need to install the respective Micropython libraries on the Pico. To do that, I'll go to Tools, select Manage Packages. On the Manage Packages search bar, I'll type in BME280 and click on Search. Then I'll proceed by selecting the Micropython BME280 and clicking on Install thereafter. Next, to install an MQTT client library on the Raspberry Pi Pico W, I need to first connect it to a Wi-Fi network. So to do that, I'll go to the terminal and execute the following set of commands. Next, I'll install the package installer for Micropython. And then when Micropython pip is successfully installed, I'll go ahead and import it. And then I'll use Micropython pip to install an MQTT client library called Micropython MQTT.simple. I'll start by installing the Micropython MQTT.robust library, and then followed by the Micropython MQTT.simple library. Now, it's important to mention here that the installation of Micropython MQTT.simple can present a few challenges, as I have experienced. If that happens to you, there are a couple of things that you could try to resolve the situation. First of all, try using the latest Micropython firmware on your Pico W. If it doesn't work, use Thonny to navigate into your Raspberry Pi file directory and then delete the folder called lib. Now that the required packages for my IoT project are installed, I can now proceed with the code. I already have the code, so we're going to go through it together. First, I'm importing the machine library to gain access to the pins of the Raspberry Pi for my I2C communication. Next, I import network to access my Wi-Fi network, UTime for time delay, BME 280 library, and lastly the MQTT library. Then I initialize my Wi-Fi connection details by specifying the SSID and password. Next, I activate my Wi-Fi connectivity on the Raspberry Pi and connect to my Wi-Fi network. After that, I check to see the status of my Wi-Fi connectivity. Next, I initialize my Raspberry Pi's I2C interface, and then I define a method for connecting to my MQTT broker. I'm using a Hive MQ-Cloud MQTT broker, which I've already created, and I'll show you how to do that shortly. First, let's quickly go through the MQTT connection details. Now, it's important to mention here that these connection details are specific to a Hive MQ-Cloud MQTT broker. Under server, you put the MQTT broker URL address. For port number, you put 0, even though my broker is at port 8883. Next, I have MQTT client username and password, which I've set on my Hive MQ Cloud portal, and SSL is set to true. And then finally, under SSL parameters, I've put the server hostname of my MQTT broker. Again, these settings are specific to a Hive MQ Cloud broker, so if you're using a different MQTT broker, you're probably going to have different settings. And then next, I go on to connect to my MQTT broker by calling the connect MQTT method. Before we proceed with the code, let me show you how I created the MQTT broker that my code is connecting to. On the Hive MQ website, you go to Cloud, select Hive MQ Cloud, and then here you can sign up for a free account that allows you to connect up to 100 MQTT clients. When you sign up, the MQTT broker cluster is automatically created for you, so you just need to copy its URL by going to Manage Cluster, and then copying this cluster URL. And then you also need to specify the username and password for connecting to your MQTT broker, and you do that under Access Management. This is where you can create your username and password that MQTT clients can use to connect to this broker. So I've already done that. Let's get back to the code. Now, after connecting to my MQTT broker, I've created a method for publishing messages to that MQTT broker. So this method takes in topic and value parameters and then goes on to publish the value under the specified topic. And then finally, I have my super loop for executing the main logic. First, I'm reading the sensor data from the BME 280 sensor and assigning it to temperature, pressure, and humidity variables. Then, after printing the sensor readings, I'm using the publish method to publish the sensor data as MQTT messages under the topics Pico W/temperature for temperature data, Pico W/pressure for pressure data, Pico W/humidity for humidity data. And then after that, I delay for 5 seconds before reading and publishing again. Okay, now that I have my code ready, I can go ahead with deploying and running the code on my Raspberry Pi Pico W. To do that, I'll go to the menu and click on Run. and then I'll proceed by selecting Run Current Script. Okay, so as you can see, my code is executing. So at this stage, we are successfully running code for reading the BME 280 sensor data and publishing the data to an MQTT broker in the cloud. But for our project to be complete, we need to subscribe to this MQTT data from anywhere on the internet and visualize it to know what the current temperature, pressure, and humidity is in my demo room. To do that, I'm going to use Node-RED. In case you're not familiar with Node-RED, this is a very useful and easy to use drag and drop tool for connecting IoT or online services. So here, I'm using MQTT nodes to connect to the same HiveMQ Cloud MQTT broker and subscribe to Pico W on the first node, and then you have Pico W/pressure on the second node and Pico W/humidity on the bottom node. Next, I'm passing the MQTT payloads to function blocks to strip out the decimal value, since the sensor reading comes as a string with units of measurements. So this is the simple equation that does that for the temperature reading. This is the one for pressure, and then this is the one for humidity. And then after that, I pass the decimal values to gauge visualization nodes from a dashboard package that are installed on Node-RED. So as you can see here, we're using a gauge to display temperature with a range of 0 to 100. And here we're displaying pressure with a range of 0 to 1000. And then lastly, here we're displaying humidity with a range of 0 to 100%. And if we open up the dashboard page, which is localhost at port 1880/UI. So here, I'm visualizing live MQTT data from my Raspberry Pi Pico W. I'll breathe into my sensor to change the sensor readings. And when I do that, you can see the value of the humidity and temperature go up. So I've successfully demonstrated how to build a simple IoT project using Raspberry Pi Pico W, Micropython, and MQTT. I hope you found this video useful. If you did, please give it a thumbs up. Thank you for watching.